Good morning. Hello to all. I am Dr.A.K, Professor of Chemistry. Today I am going to discuss some numericals based on entropy. Last class I have discussed about the entropy and spontaneity. Entropy and spontaneity. Now I am going to discuss some numericals which is asked in examination. Then this actually numericals are very conceptual. You can answer very easily without any tension if you will understand the question. And so try to understand the question I am reading and then quickly you can answer. I hope if you have understood the concept of entropy and spontaneity. Okay, now I am telling about the question. Predict in which of the following entropy increases/decreases. First, a liquid crystallizes into a solid. Second, temperature of a crystalline solid is raised from 0 Kelvin to 115 Kelvin. Third, sodium bicarbonate solid, it dissociates into sodium carbonate solid plus carbon dioxide gas plus H2O gas. And fourth one is H2 gas is dissociating into 2H gas. Then these four parts you have to explain. Okay, you have to predict. This is the question. Again I am reading and giving explanation. Predict in which of the following, four questions they have given, four parts are there. Predict in which of the following entropy increases/decreases, means entropy is increasing or decreasing in the following questions. Then first is that a liquid crystallizes into a solid. A liquid crystallizes into a solid. Then entropy, I am remembering you, I am making just telling you about the entropy. Entropy is the measure of disorderliness. Keep in mind a disorder. And now on this concept you have to answer. A liquid crystallizes into a solid. Then what will be the entropy? Entropy will increase or decrease? Then think. After freezing, the molecules attain an ordered state after freezing, because a liquid crystallizes into a solid, just like water is converting into ice. Then what will be the entropy? Entropy will increase or decrease because it is converting to solid. Then explanation I am telling you. After freezing, the molecules attain an ordered state and therefore entropy decreases because it is becoming stable. It is arranging in a ordered way. Ordered way means stability, or entropy decreases. Disorder means entropy increases. Now second, temperature of a crystalline solid. Temperature of a crystalline solid is raised from 0 Kelvin to 115 Kelvin. Means temperature was less, now we are becoming more, 115 Kelvin, from 0 to 115 Kelvin. Then entropy will increase or decrease. Then now it is very clear, because temperature is rising. Then when temperature will rise, kinetic energy will rise, because molecules will be in motion, it will be disordered, and that's why entropy will increase. At 0 Kelvin, constituent particles are static and entropy is minimum. If temperature is raised to 115 Kelvin, these begin to move and oscillate about their equilibrium position in the lattice, and system becomes more disordered. Therefore, entropy increases. Third part. Sodium bicarbonate solid, that 2 sodium carbonate solid, it dissociates into sodium carbonate solid plus carbon dioxide gas plus H2O gas. Okay, then in this situation, what will happen? Entropy. Then now again, by the concept of entropy, it is clear that entropy will increase because decomposed due to high energy. This decomposed means energy will be released. Then again molecules will be disordered. Then now entropy will increase. Okay. Then reacted sodium bicarbonate is a solid and has the entropy. Okay. Reactant sodium bicarbonate is a solid and it has low entropy in the beginning. Among products, there are one solid and two gases. Therefore, the products represent a condition of higher entropy, means entropy will increase. Now, next part, last part, that is the H2 gas is decomposing into atomization, you can tell, converting into 2 atom of gas, H atom. Then in this also what will happen? Now molecule was there, now it is becoming into atom. Then here what will happen? Then here one molecule gives 2 atoms, that is the number of particles increases, leading to more disordered state. 2 moles of H atoms have higher entropy than 1 mole of hydrogen. Okay. Then this I have told you, that very conceptual question I have explained. Now second question, again I am telling you, that is also very important. But this you have to think. Actually, pen and paper you should keep with you whenever you are attending the class. When pen and paper, just keep with you. Important things at least you should write down. Okay. Now question I am telling you. For oxidation of iron, 4 Fe's, I am telling about the equation. Okay, reaction I am telling you. 4 Fe solid plus 3 O2 gas, it gives, means products are Fe2O3, 2 Fe2O3 solid. Now this is the given equation, 4 Fe solid plus 3 O2 gas, arrow sign, product is 2 Fe2O3 solid. Then for oxidation of iron, reaction is given, entropy change is, for this reaction, particularly for oxidation of iron, entropy change is given minus 549.4 joule per Kelvin. Oxidation of iron, entropy change is minus 49.4 joule per Kelvin per mole at 298 Kelvin. In spite of negative entropy change of the reaction, entropy change is minus 549.4 joule per Kelvin per mole. at 298 Kelvin. In spite of negative entropy change of this reaction, why is the reaction spontaneous? This is the question. Again I am telling you question. For oxidation of iron, reaction is given 4Fe solid plus 3O2 gas, and it is giving 2Fe2O3 solid. Entropy change for this reaction is minus 549.4 joule per Kelvin per mole. Okay, at 298 Kelvin. In spite of negative entropy change of the reaction, why is the reaction spontaneous? Okay, I told you for the if it is a value is negative, then it should not be spontaneous. It should be non-spontaneous, because this value, entropy delta S value is minus 594.4 joule per Kelvin per mole. Then if it is a minus, then why it is spontaneous? Delta S should be more for the spontaneous. Entropy change should be there positive, but it is negative. Negative means it should be stable. It should not be, this reaction should not be spontaneous, but it is spontaneous. Why? Value is negative. Then even the negative value, reaction is spontaneous. Why? This is the question. And now try to understand explanation. See, one decides the spontaneity of a reaction by considering, already I have told you when theory I was discussing, that one decides the spontaneity of a reaction by considering this delta S total. Delta S total means change in entropy, total change in entropy. That is the criteria to tell about the spontaneity. Then total means what? Delta S system plus delta S surrounding. Correct? Total will decide, not only system, not only surrounding. Okay. For calculating delta S surrounding, we have to consider the heat absorbed by the surrounding. Okay, what is this thing, which is equal to minus delta H R reaction, delta H R small r reaction, standard delta H R at temperature T. Okay, then delta S surrounding, you have to think for both delta S system and delta S surrounding. Then delta S surrounding for calculating or for calculation or for calculating delta S, we have to consider the heat absorbed by the surroundings, which is equal to minus delta standard delta H minus delta HR. Okay, minus delta R H control, standard heat of reaction at temperature T. At temperature T, entropy change of the surrounding is, we know, already told you the relation delta S surrounding. Okay, that is equal to minus delta H divided by T at constant pressure. This relation already I have told you that, and last class I sent the numericals also. Okay, numerical that this formula was used. Q upon T, you are knowing, Q upon T, Q reversal by T, that Q here is equal to minus delta H. Okay, because that is if heat will decrease, then minus sign you have to give. Okay, then delta H surrounding, this formula is there, keep in mind, minus delta H divided by T at constant pressure. Then now here that delta H value is given. Okay, and one thing more, in question also they have given, delta HR they have given. Delta H for this reaction is minus 1648 into 10 to the power 3 joule per mole. This is given in question. Delta H value, delta HR. Delta means heat of the reaction, standard heat of reaction, that is given. Okay, that is minus 1648 into 10 to the power 3 joule per mole. It is given. Then very easily you can calculate delta S surrounding. Delta S is equal to minus delta H divided by T at constant pressure. Then delta H value is given, that is minus 1648 into 10 to the power 3 joule per mole is given. Then this divided by 298. Okay, then you will get, you know that minus will become plus. Already one minus is in formula, minus delta H divided by T, and delta H value is minus 1645 into 10 to the power 3 joule per mole. Then minus becomes plus, and then after dividing it, temperature is 298. Then delta H divided by T, the T is 298 Kelvin. Then after this minus plus, and after this, after dividing by 298, its value will come 5530 joule per Kelvin per mole. 5530 joule per Kelvin per mole. Okay, thus here total change for this, total entropy change for this reaction. Okay, that is the, you can say, delta surrounding you have calculated 5530 joule per Kelvin per mole. Okay, then this is the delta S surrounding. Now then you have to calculate total entropy change. Thus total entropy change for this reaction, that is a delta S total, is equal to 5530 joule per Kelvin per mole, plus that is also given these things, heat of reaction in the question they have given, that is the entropy change is 549.4 joule per Kelvin. This is given entropy change for the system. Okay, means this reaction means system, you are thinking for that. Then now both entropy change you add, then what you will get, that is you will get 5530 joule per Kelvin per mole, plus in bracket you can write minus 549.4 joule per Kelvin per mole, then plus minus, then from 5530 you just deduct the 549.4, then you will get value in plus, because 5530 is more than 549.4, then you will get answer in plus, means that is equal to 4980.6 joule per Kelvin per mole. That is the total entropy change, means delta S total you got, that is equal to plus 4980.6 joule per Kelvin per mole. This shows that the above reaction is spontaneous, because total decides, then total is positive. Total is in positive, then positive means what? That is the entropy change is increasing, means reaction is spontaneous. Total entropy change decides the spontaneous, it must be positive. Delta S must be positive, then you have value is positive, and too much positive 4980 joule per Kelvin per mole. This I have told you about the numericals. These are the sufficient concept what I told you, that is sufficient to solve any numericals based on entropy and spontaneity. Now I am going to discuss again a new concept, new terms that you might be not knowing, particularly 11th student. Okay, what is that? Then Gibbs energy and spontaneity. Gibbs, G-I-B-B-S, Gibbs, it is a name of scientist. Gibbs and Helmholtz energy, you might have heard. Gibbs and Helmholtz, H-E-L-M. Okay, Helmholtz, H-O-L-T-Z. Then okay, that also I will come, but that is not in your syllabus. Then these are the name. Gibbs is the name, Helmholtz is the name of the scientist. Then now what is the Gibbs energy, you have to understand. And Gibbs energy and spontaneity. Entropy and spontaneity means delta S. And now we are going to understand Gibbs energy and spontaneity. What is this energy? You have to understand. That is represented by G, capital G. And standard means always you have to put subscript 0 like that above the you can say, just like S, above S you are writing one 0. Here also above the 0, above the G you have to write a small 0 like that. That is the standard. Okay, standard has same meaning everywhere. Same meaning means constant temperature and constant pressure. Standard temperature, standard pressure. Standard temperature is 273 Kelvin. Standard pressure is 1 bar. And normal temperature is 273 plus T, 298. And 1 atmospheric pressure, 1 atm. And now I am going to discuss Gibbs energy and spontaneity. Listen carefully because this term is new for you. We have seen that for a system, it is the total entropy change, means delta H total, which decides the spontaneity of the process. But most of the chemical reaction fall into the category of either closed system or open system. Entropy, what we have discussed, that was for isolated. Okay, but most of the chemical reactions fall into the category of either closed system or open system. Okay, open means that both mass and energy can be transferred, and closed means only energy can be transferred, not the mass. Then most of the chemical reactions fall into the category of either closed system or open system. Therefore, for most of the chemical reaction, there are change in both enthalpy and entropy. Enthalpy means H, entropy means S, delta S, and enthalpy means that is the delta H. The most of the chemical reaction, there are change in both enthalpy means delta H and entropy delta S. It is clear from the discussion in what we have previously I have discussed, that neither decrease in enthalpy nor increase in entropy alone can determine the direction of a spontaneous change for the synthesis. This is again very important point I am telling you. Only delta H and only delta S will not decide, can't tell very clearly about the spontaneity of the reaction. Third things also you have to know. For full confident, for spontaneity, only delta H will not tell. Okay, delta H also fails. Only in the beginning I told you, you can't tell boldly. Some places it fails. Delta S also, it will not tell fully. Okay, it will tell approximately, not 100% correct. Then one more thing, that is the free energy, that if you will consider all three delta G free energy also is a state function. It depends upon initial and final state. Okay, just like a delta H, delta S, enthalpy, entropy, free energy, all are the state function. Then it depends upon delta G also. Okay. Then only you can say the decrease in this things, enthalpy, neither enthalpy nor increase in, neither decrease in enthalpy or neither decrease in enthalpy nor increase in entropy alone can determine the direction of a spontaneous change, in which direction change will take place. Direction can't tell. Then how will you understand? Then these three are related by one equation. G, H and S. These three terms are related to each other. Okay. For this purpose, we defined a new thermodynamic function, Gibbs energy, that is called Gibbs energy or Gibbs function. Gibbs energy or Gibbs function. Just like it is also energy. All are energy. Enthalpy is also energy. Entropy is also energy. And Gibbs is also energy. Gibbs energy, also called Gibbs function. Just like enthalpy function, entropy function, Gibbs function. Okay, either tell energy or function. Then how they are related? Then it's a relation I am telling you. This also you remember it because this is the always it is used while solving the numericals, and that is the relation I am telling you. G, capital G is equal to H minus T into delta S. Ts first to understand. G is equal to H minus Ts. T is the temperature. You know that entropy is related to temperature. Entropy is related to temperature. Hence, wherever entropy will be there, temperature will be there. Okay. Then relation is capital G is equal to H minus Ts. Don't forget. And this is the general relation I told you. But now you know that this is the state function. Absolute in thermodynamics, absolute value has no value, no importance. Absolute value you can't determine. Neither H, neither internal energy, not enthalpy, nor entropy, anything, even G also, that is absolute value of H, absolute value of U, absolute value of these things. S you can't determine, impossible. Okay, then like that, this G, free energy also it is impossible. Then what is the possible and what is required? Then delta G, change. We are interested in thermodynamics, delta G has value. Okay, how much change took place, that can be determined. Then like other, here only G you can't write. G initial, G final. Then final minus initial, delta G. Okay, and H like that way, delta H. And S also like that way, delta S. But temperature will be T at particular temperature. That's why same relation you can write like this: delta G is equal to delta H minus T into delta S. You have pen and paper, then you should note down. These are all important things, at least you note down. Okay, pen and paper you should keep. Then delta G is equal to delta H minus T into delta S. Gibbs function G is an extensive property and a state function. Okay, the change in this question is asked, Gibbs function is extensive or intensive property. Already I told you, discussed all things. Then Gibbs function is an extensive property and is a state function. The change in Gibbs energy for the system, that is the delta G system is equal to delta H system minus T into delta S system, and again minus delta S system delta T. Here I want to tell you, here 4 terms you have written. 4th term also you have written. I told only about the 3. That is the G is equal to H minus Ts. I told like this. But here, if you will make it, I can say change delta, if you want to write in the term of delta G, delta H and delta S, then one more term will increase. How 4th term came? Means delta G is equal to delta H minus T into delta S minus S into delta T. This minus S into delta T, all are for system. Hence G system, delta G system you should write SYS, delta H write SYS system. You make habit. T into delta S again SYS minus S system into delta E. Then 4th one, how did it come? 4th? Then now here actually it came by mathematics, calculus. You know, you will take integration if you will take up these things, Ts. If you will integrate Ts from limit 0, you can say initial to final limit, then T into S is there. Then you know that one time T will be constant, then you can integrate only S. Correct? Other time S will be constant, then T you can integrate. Correct? That's why 2 term came by integration. Because one time T will be constant. That's why you have written T into delta S. T into delta S, because T is constant and S is changing from initial to final. That's why T into delta S minus. Again, second time what will happen? S will be constant and T will change. Means from initial to final. That's why now this time 4th term came, minus S system into delta T. Means one time temperature is constant, then for the constant no integration. Correct? For the constant no integration. That's why T into delta S. Again second time minus S into delta T. Okay, one time T into delta S, other time S into delta T. Okay, at constant temperature, when temperature suppose you are keeping constant, then 4th term, that is a delta T is equal to 0. Yes, when temperature is constant, if you are any reaction is going at constant temperature, then its delta T is equal to 0. Then 4th term will come 0. 4th term, because delta T is equal to 0, then S into 0, that is equal to 0. Correct? Then at constant temperature, delta T is equal to 0. Okay, then only 3 term will remain. That is a delta G is equal to delta H minus T into delta S. Here T is changing, but you have considered delta. When temperature is constant only, then delta T will be 0. Okay, then now you have this main relation delta G is equal to delta H minus T into delta S. All are for system, means delta G system is equal to delta H system minus T into delta S system. Okay, this is a very important relation. Very well, it is based on G is equal to H minus T into S. Based on that only, both are the same. This is only telling about the change, and first one, that is only for remembering point of view, that is good, that is correct. Okay, then now I told about the relation between 3, delta G that is equal to delta H minus T into delta S. Okay, thus Gibbs energy change, delta G is called Gibbs energy change, that is equal to enthalpy change minus temperature into entropy change, and is referred to as the Gibbs equation. This is also called Gibbs equation, one of the most important equation in chemistry, particularly in thermodynamics. Here we have considered both terms together for spontaneity. Okay, for the spontaneity we have considered both. Terms together for spontaneity. Energy in terms of delta H and entropy, a measure of disorder. Both you are considering. Energy, that is the delta H also you are considering, and for disorder delta S also you are, both term you are considering, delta S and delta S. Then you are getting delta G. Okay. Now you can understand that the delta G value depends upon change in enthalpy and this entropy change. Both will decides delta G, because delta G is related to enthalpy. Delta H means heat, more heat, delta H minus T into delta S, that is the energy also. Then energy difference between enthalpy, change in enthalpy and entropy, that is the delta G. Both are, some differences are there in both delta H and delta S, T into delta S. Some change in energy is there. That change in energy has also value. That's why new term came, delta G. Okay. Then dimensionally, if we analyze, we find that delta G has units of energy, because both delta H and the T into delta S are energy term. Since T into delta S, it's a, what is this unit? Kilojoule per Kelvin. Okay, kilojoule per Kelvin. Okay, temperature is Kelvin. Temperature is called Kelvin, and delta S, that is a joule per Kelvin. Then it will be joule only. Hence delta G is joule, energy, only joule, J, capital J. Was T into delta S. Then T is Kelvin. Temperature you can tell Kelvin, and delta S you will write joule per Kelvin. Then Kelvin will be cancelled out. Only J will remain. Hence it is the energy. Delta J is in unit is J. Question is asked. Capital J, that is the joule, means energy. Now let us consider how delta G is related to spontaneity. How delta G is related to reaction, spontaneity. Then now we know that delta S is equal to delta S system plus delta S surrounding. If the system in thermal equilibrium, means heat wise they are equal, almost equal, not 100% equal, equilibrium thermally, that is called thermally equilibrium, means heat wise you are considering. If the system is in thermal equilibrium with the surrounding, then the temperature of the surrounding is same as that of the system. Thermal equilibrium means what? For the reactant and for the product, temperature is same, means reactant is converting to product is again coming back to the reactant to product to reactant. Then at equilibrium, backward and forward reaction will be the same. Okay, they will be in equilibrium, it is, you can't distinguish. Then that's why temperature will be same, even the pressure also remains same, temperature and pressure both. If the system is in thermal equilibrium with the surroundings, then the temperature of the surrounding is same as that of the system. Also, increase in enthalpy of the surrounding is equal to the decrease in the enthalpy of the system. It is obvious. When from the system heat is going outside, then outside it is going, that is the negative, means heat is in system, heat is decreasing, but it is going outside. Whatever it is going outside, that amount decreased in system, means the system heat is decreasing and surrounding it is increasing. It is obvious. Then here this also you have to consider. Also increase in enthalpy of the surrounding. Increase in enthalpy of surrounding is also equal to decrease in enthalpy of the system. Therefore, entropy change of surrounding, then entropy formula you know, the entropy change of the surrounding, that is the entropy I am talking about, then entropy change is equal to of the surrounding, that is the delta S, SURR, you can surrounding, that is equal to delta H surrounding divided by T, and that is equal to minus delta H system, minus delta H for the system, minus always you can write, okay, minus delta H system divided by T, delta H divided by T, this is the delta S, you keep in mind, and for system minus you write, for the surrounding you plus you write, for the surrounding plus, and for the system minus, okay. Then here, because system is stable, and when it will entropy will increase, then it will be plus. S will be plus, means disorder, keep in mind. Then delta S surrounding you can write, that is equal to delta S surrounding divided by T, but this is equal to minus delta H system divided by T, because in one system is heat is going outside, the other it is decreasing, that's why minus term you are writing here for the system. Then this delta S surrounding is equal to delta H surrounding divided by T, and that is equal to minus delta H system divided by T, okay. Then now again rearrangement you can do for this equation, that is a delta S total. To delta S total if you want to write, then you add both, for system and surrounding you add, means delta S system plus you can say delta S surrounding, and delta S surrounding you can write minus delta H system divided by T, correct or not? You can write delta S system plus delta S surrounding you have to write, then for the surrounding you can write in the term of system you can write, that is the minus term, then minus delta H system divided by T, then this you have written in a bracket, in the place of delta S surrounding you have written minus delta H system divided by T, then this value minus delta H system by T, you keep in mind. Then now if you will rearrange this, that is the delta S total, that is equal to delta S system plus in bracket you have written minus delta S system by T. Then if you will simplify it, then you will get, okay, nothing that your mathematics you have to do, because down divided by T is there, just 2y5 plus 1y3, you are solving it, na? Like that way here you have solved. Then after that you will get T into delta S total, that is equal to T into delta S system minus delta H system. You will get this relation just simply by simplifying. I told you, just simple calculation you are doing in mathematics. 2 by 3 and 5 by 6. Then how there you are simplifying, and cross multiplication you can do. Then you will get this relation, T into delta S system, that is equal to T into delta S system minus delta H system. This you will get. For a now come to the chemistry, now it is applying, that was the mathematics. For a spontaneous process, you know already I have told you, for condition for a spontaneous process, delta S total must be greater than 0. So what we will do here in this relation, that T into delta S system minus delta S system, now it was this T into delta S system minus delta S system, this is the total actually, T into delta S minus delta H system, T into delta S, what you got after simplifying, that is actually total. Okay, that is the total entropy is equal to, you got T into delta S, after the simplification you got T into delta S is equal to T into delta S system minus delta H system. It means this should be greater than 0. T into delta S must be greater than 0, or in another way, T into delta S system minus delta H system, that must be greater than 0. Okay, then T into delta S system minus delta H system, that is greater than 0. Then if you will take minus, to just keep it out. Minus, if you will revert the reaction, greater than 0 is there, then greater than 0, if you write less than 0, then sign will change. Now you are writing greater than 0. If less than 0 you will write, then what will happen? Only sign will change. Okay, means T into delta S minus delta H system is greater than 0. Then if this term is less than 0, then how will you write? Then you can write this T into delta S minus delta S system, that you write in bracket, this is written in bracket, then that is greater than 0. Then if you want, you can say less than 0. Then you have to write, you have to change the sign, that is the, now outside you write a minus, and inside the bracket you write same things, means delta H system minus T into delta S. Okay, you can write. Okay, sign will change. If you will write less than 0, then inside sign will change, means minus will become plus, plus will become minus. Means in the beginning it was T into delta S, then that plus T into delta S was there, that will become minus T into delta S, and other term minus delta H system was there, that will become plus delta H system. That is actually you can write less than 0. Okay, in any way it should not change, you can write in any way, but mathematics should not change. If you want to keep it out, minus outside T into delta S, T into delta S minus delta H is there. If you want to keep minus outside, then what will become? Delta H minus T into delta S, that is equal to G greater than 0. That greater than 0 you can write in any way, okay. Minus you can write minus, if you will take it outside, then minus term will become plus, and T into delta S, which was the plus, that will become minus. In any way you can write, that is not a problem. Then now this equation means minus outside, right, in bracket you can write delta H first to write, delta H system minus T into delta H system, that is greater than 0. You have just simply rearranged, nothing you have done, okay. Then this equation is again important, only rearrangement you are doing, nothing new. Using equation, this equation, the above equation can be written, because see why you have done like this, outside minus you have written, and in bracket delta H system minus T into delta H system. Why did you write? Because this term is equal to delta G. This term already I discussed at the beginning, that this H minus T into delta H minus T into delta H, that is equal to G. That's why you have written like this. Delta H is equal to H minus Ts, that is equal to G. G is equal to H minus Ts, I told you, na? Then only on that basis you have written delta H minus T into delta S. That actually is equal to delta G. That's why you have made this type of change. Then now inside the bracket what you have written, delta H system minus T into delta S system, that is equal to delta G you can write, and outside minus is there, hence minus delta G is greater than 0. This is the again condition, okay. Minus delta G is greater than 0. If minus delta G value is greater than 0, then reaction will be spontaneous. This is the new concept in term of change in Gibbs free energy, also called free energy, okay. Then minus delta G is greater than 0, then less than 0, in term of less than, what will happen? Minus will become plus, then delta G is less than 0, that is again you can tell in other way, that is the, you can say, spontaneity. Reaction will be spontaneous when delta G value will be less than 0, plus delta G value will be less than 0, or minus delta G will be greater than 0. Okay, this is the important things I told you. Then minus delta G is greater than 0. This is the important relation, okay. And again, if you will put the delta G value, already delta G value, not delta H minus T into delta S, then in the place of delta G you write delta H minus T into delta S, because it is a minus delta G, then what you will do, that you have to multiply all the things by minus, okay. In term of less than 0, you can rearrange, minus delta G is greater than 0. Any one relation you keep in mind, and delta G is equal to delta H minus T into delta, that is sufficient. Anytime you can put the value of delta G, then you will get relation between delta H and T into delta H, that's enough, okay. Then this is a rearrangement, we are not doing anything. Then delta H is the enthalpy change of a reaction, I am telling you, okay. In terms of less than 0, delta G is equal to delta H minus T into delta S is less than 0, okay. In terms of less I am talking about. Then in this, why you are doing like this? Because it will be easy to understand. Okay, minus delta G is greater than 0. This is a very, very important thing. Only on that basis only you are rearranging and writing, nothing you are doing more. Then delta G is equal to delta H minus T into delta S, and that is equal to less than 0. Whatever I have discussed in the beginning, that is a delta G is equal to delta H minus T into delta S, that you have related with 0, and that is equal to less than 0. Then now this equation you have to see. Delta H is the enthalpy change of a reaction. T into delta S is the entropy which is not available to do useful work. Okay, this is important things. Delta S means entropy. Entropy minus T into delta S, that is I am talking about this. T into delta S, entropy change. Entropy change is the disorder you are knowing. Then this T into delta S means are talking about the entropy is the energy. This is the energy which is not available to do useful work. Then what is the difference between delta H and T into delta S? That is equal to delta G, and actually delta H value change in enthalpy, that is also called that is the energy available to do work. Then difference of both delta H minus T into delta S, whatever energy you are getting, that is the energy available to do work. Then free energy, this is called free energy delta G. Then simple meaning of free energy is that energy available to do the work. Okay, in a simple way. What is the free energy? Then free energy is the energy available to do the work. Okay, then delta H here is the enthalpy change of reaction. T into delta S is the enthalpy which is not available to do the work. So delta G is the net energy available to do useful work, and is thus a measure of free energy. That is the delta G, net energy available to do useful work, and is measure of the free energy. For this reaction, it is also known as free energy of the reaction. Delta G gives a criteria for spontaneity at constant pressure and temperature. Delta G gives a criteria for spontaneity. First criteria, that if delta G is negative, then what will happen? If delta G is negative, means less than 0. If delta G is negative, okay, the process is spontaneous. If delta G is negative means less than 0. Okay, delta G, I am talking about positive delta G. Already told you, minus delta G is greater than 0. Minus delta G, then plus delta G means what? Reverse. Minus delta is greater than 0, then plus delta is less than 0. That is the criteria. If delta G is negative means less than 0, the process is spontaneous. This is a very, very important relation. If delta is negative, the process is spontaneous, means less than 0. Then reverse way, if delta G is positive, means greater than 0, the process is non-spontaneous. I have told you. Okay. Then this, by seeing the formula, that is a delta G is equal to delta H minus T into delta S, that is the less than 0, then you can put some other condition also. I will tell in the next class. Now I am stopping here. Major criteria I told you, that if delta is negative, always become delta is negative means less than 0, and reaction is spontaneous, and in term of 0, minus delta G is greater than 0, minus delta G is greater than 0. In a reverse way, plus delta G is less than 0. Okay, less than 0. Then if delta G is negative, the process is spontaneous. One you keep, other automatically you will understand. Okay, delta G must be negative for spontaneous. I am stopping only here. Next class again we will meet. Thank you.